4, Quadratics Exploration Part B. Let's look at this first example. 3. Y equals x minus 2 times x minus 1. What form is that? Well, factored form, and that's also called intercept form or x-intercept form. Well, what can we tell right away from this function? Well, since it's in factored form or x-intercept form, we know our x-intercepts right away. So I can write down my x-intercepts. Take a moment to see if you write them down correctly. Remember, inside opposite. So my two x-intercepts are 2, 0, and 1, 0 because my factored form is x minus 2, x minus 1. So inside opposite. Let's go ahead and plot those and see if we can answer this next question. What is our axis of symmetry and how do we know? Well, think about what a parabola looks like. If I know I have two x-intercepts right here, could you kind of imagine the parabola going through those two x-intercepts? Where would that axis of symmetry be? Right between those two x-intercepts. So right smack dab in the middle. And I can kind of visually see that that's going to be at x equals 1.5. But let's see if we can mathematically come up with that 1.5 as well. Okay, if I wanted to find the axis of symmetry numerically, well then I just add my two x-intercepts together and then divide by 2 to find that middle. So dividing by 2 is the same as multiplying by 1/2. So I'm going to write 1/2 times, well, my first x-intercept 1 plus my second x-intercept 2. So x-intercept plus x-intercept equals, well, 1 plus 2 is 3, so 1/2 times 3 is 3/2, which is 1.5. Since I know the axis of symmetry, what do I automatically know about my vertex now? The x-coordinate. So I automatically know the x-coordinate of my vertex is 1.5. How do you think I'd find the y-coordinate if I know the x-coordinate? Plug in the x-coordinate. Sure. So if I plug in 1.5 for my x value, I've got 1.5 minus 2 times 1.5 minus 1. So make sure you do what's in those parentheses first. 1.5 minus 2 is negative 0.5 or negative 0.5. 1.5 minus 1 is positive 0.5. And then I multiply those two together. So what's negative 0.5 times 0.5? Well, let's just look at the 5s. What's 5 times 5? Well, 25. How many decimal places do I have? 1, 2. So I can move my decimal place 1, 2. So there's my negative 0.25. So my vertex is 1.5, negative 0.25. So while I have my vertex, why not write vertex form? So right here, we have our vertex form, y equals a times x minus h squared plus k. Okay, well I have my h and k because I have my vertex. What's a? A is that coefficient out in front. Do I have a coefficient out in front? Well, yeah, I don't see it, but that just means that a is 1. I have a little 1 sitting there out in front. So I can write y equals 1, but I don't really need to write that, x minus my x-coordinate of my vertex, 1.5, squared, don't forget that little square, that's what makes it quadratic, plus my k is negative 0.25, so I'm going to write minus 0.25. So the next question asks us for standard form. Well, I could convert vertex form to standard form, or I could convert factored to standard form. I'm going to convert factored to standard form because that's so much easier. I just have to multiply out. So my standard form is y equals x squared minus 3x plus 2. What does standard form tell me? The y-intercept. So the y-intercept is this last little c value here. So y-intercept is going to be 0, 2. Since I now have yet another point, I can use the symmetry and start graphing. So let's get what we know graphed now. I know my vertex. Be sure to label your vertex, especially when we don't have integer coordinates like this one. I also plotted my y-intercept. Do we know a fifth point? For sure. We can use symmetry. Let's count. The y-intercept is 1.5 units away from my axis of symmetry. So 1/2 and 1 unit away in the right direction would be my symmetric point. So that looks like it's 3, 2. Let's draw our graph. Look at that fabulous parabola. Be sure to fill in the rest of your table. All right, go ahead and check. Mrs. Peart, you want to take the next one?
Happy to take over right now. Alrighty, example 4. Which form is this one in? You're right, standard form, which of course, what do we know? Go for it. Yep, the y-intercept at 0, 5. So I went ahead and plotted the y-intercept and wrote it in my box. Next, can we convert to factored form? Well, luckily we have the skills, we can do it. So let's write down our standard form, y equals x squared plus 6x plus 5, and then let's go ahead crisscross. Here we go, y equals x plus 5 times x plus 1, which of course, now that we're in factored form, what do we know? Go for it. You should be pausing along in this video anytime you think you know the next step. We already know a ton, but we always need to get the vertex for each parabola. So let's do that. First of all, from factored form, we already kind of know what the axis of symmetry is because it's right in the middle of that -5 and -1. So if I add -5 plus -1 and then divide by 2 or multiply by a half, same, I'm going to get 1/2 times -6 or -6 halves, which is -3. My axis of symmetry is at -3. Now, mind you, we have the graph, so it's pretty easy just to count in the middle as well. Okay, I want us to slow down here for a second because this is really cool. We know how to find the axis of symmetry from factored form. Let's take a look at standard form and see if we can start figuring this out. Now, with factored form, of course, it's intercept plus intercept, divide by 2 or multiply by a half. But don't we actually have part of that in standard form? Well, yeah, look at that. -1 plus -5 is -6. If I look up at standard form, there's a 6 in there, right? But it's a +6. Why did it end up positive? Inside opposite. So take a look at our factored form. When I have y equals x plus 5 and x plus 1, and I just want to look at that middle term, right? Because the 5 and the 1 give me the x-intercepts. So I'd have 5x and 1x, so that would give me my 6x in the middle. But it doesn't account for taking the opposite. So that's why I would need -b. Do you remember that standard form is y equals ax squared plus bx plus c. So that middle term with the b value, we take the opposite of it because it comes from those intercepts. So for standard form, we go ahead and say the axis of symmetry is x equals -b from standard, so that's right in front of the x, divide by 2. But wait, that's not exactly correct. This is correct this time because a happens to be 1. But when a isn't 1, then we have that dilation that's been multiplied throughout. Therefore, I have to divide it back out. So really, it ends up being -b divided by 2 times a. So let's try this out on our standard form. I look up at standard form, the b value is 6, so I take the opposite of 6 and I divide by 2 times a, which is in front of x squared, and that happens to be 1 right now. Well, -6 divided by 2, check, that's -3. We have the same axis of symmetry. We'll still practice this more. We know the axis of symmetry is -3, so that means the x-coordinate of the vertex is -3, and then I just need the y-coordinate. What do? Plug it in. As you can see, I went ahead and showed that we could use either form of the equation to get the y-coordinate. It works either way. Personally, I think the factored form is slightly easier, but I don't need it. The point is we can do it either way. So now we have -3, -4. As soon as I have the vertex, I have vertex form of the equation, and I can fill out the rest of my little boxes. Go ahead and do that, and then come back. Pause. Okay, we are looking good, and really you should feel so proud of yourself for how much you already know. What was the a value? Don't think that it doesn't exist, because it does, right? A is 1. A is 1 all the way along, here in standard form, here in factored form, and also here in vertex form. The a value follows through with all 3 forms. So remember that because we're of course going to do more with this, and a will not always be 1. I already plotted the vertex. I have my y-intercept and the 2 x-intercepts. Now, just for another point, I'm going to use symmetry and get a 5th point. Let's count it out using that axis of symmetry. There it is at 6, 5. Now we can get a really good sketch for our parabola. Okay, so now we've successfully graphed from standard form. Let's look and think about what we've already learned though. Pattern points, do they apply? Well, of course they apply. We didn't have a dilation, and even if we did, we can always use pattern points for that as well. Here, let's just show that the pattern points still apply. So if we start at the vertex, I would go over 1 and up 1. Now we didn't plot that point, but it's there. Then we go back to the vertex, we go over 2 and up 4. Sure enough, that was my x-intercept. Let's do the next one. go over 3, and let's see, I'm down here at -4, so this is 4 units, and then another 5 units, because there, right? So sure enough, I go over 3 and up 9. It's just another confirmation that we know what we're doing in so many ways. Okay, I want you to go ahead, get on that assignment, and just show how much you already know. I'm really excited about our learning today.